one more factorization technique to have a look at, and that is the sum and difference of cubes. Remember, sum is the result from adding and difference is the result from subtracting. And you can see here we have two models, I suppose. One is something cubed plus something cubed, and the other one is something cubed minus something cubed, sum, difference. And it turns out that if you've got this form here, it will always factorize to this form here. And if you've got this form here, it'll always factorize to this form here. So you can see that we've got a square here, we've got a square here, and then we've got 2 times each term in the middle, and this sign is always the opposite of this sign here. Now, it's an exercise that's worth doing to do one of two things or both. Take this, expand it, and prove to yourself that when you expand it, you do get a cubed plus b cubed. It gives you a sense of how it all works. Slightly more advanced thing to check, but it would be worth it for the practice, is that if you take this and divide it by this, do you get this? You will. And similarly with this one here. Well worth doing. Pause the video. Go have a go at it yourself. Okay, so 3 examples. Going to go through them in quick order. So slide 18 there, x cubed minus 27. Do this next bit in your head or not, but basically you need to identify what the first thing is that has been cubed and what the second thing is that's been cubed. 3 3s and 9 3s are 27. It might be worth pointing out that knowing your cubes up to, say, 5 cubed would be worth it. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, and 5 cubed is 125. So knowing those cubes would be quite useful. Once you've identified the first term and the second term, it's about applying the rule. So that's x minus 3, x squared, plus 3x plus 9, which is 3 squared. Done. Okay, let's look at the harder example. 3x cubed plus 24y cubed. The suspicion is that it is a sum of cubes. You've got a cube here, you've got a cube here. 3 isn't cubed, nor is 24. But please always remember your very first step when factorizing is to see if there's a common factor. And when I look at those 2 terms there, I can see there's a common factor of 3. That leaves me with x cubed plus 8y cubed. This is a sum of cubes. I'll just point it out by using square brackets. It's x cubed plus 2y cubed. 2 cubed is 8. Now we can apply the rule. It's 3 outside of x plus 2y, x squared minus, multiply them together, 2xy plus square 2y. 2 squared is 4, y squared is y squared. Done. Next one, challenging problem. Don't be afraid of complicated expressions. I don't need to, and you don't need to, but I'm going to simplify what I'm looking at here by a quick substitution step. I usually tend to use big A and big B. Let big A equal x plus 2, big B equal x minus 2. So this now equals a cubed minus b cubed, and I can go straight for it. A minus b, a squared plus ab plus b squared. Now I'll substitute back in, So the substitution step allows me to just concentrate on the rule to start with. And once the rule is applied, I can then now concentrate on a substitution. I think it's a powerful thing to do if you get a little bit confused by the more complex terms. So x plus 2 minus x minus 2. I tend to use brackets for the substitution part to start with. Oops. X plus 2 all squared plus AB. So that's x plus 2, x minus 2, and then plus x minus 2 all squared. Complex, but not too bad. Okay. A, B, B. Okay, let's figure out this bit on the left here. That's going to be equal to x plus 2 minus x plus 2. Can you see that? Minus is plus. Now, on the right-hand side here, you might want to pause here, but there's 3 operations you have to do. You have to expand that x plus 2 all squared. You have to expand x plus 2 times x minus 2. You have to expand x minus 2 all squared. Pause the video, see if you can use the rules that you already have in order to expand these in one step. Okay, hopefully you paused the video. If you didn't, prepare to witness magic, well, at least an expansion. The first bit is a perfect square. So it's x squared plus 2 times x is 4x, and 2 squared is 4. The middle bit is a difference of 2 squares, x plus 2 times x minus 2. So that's x squared minus 2 squared, which is 4. The last bit is equal to a perfect square, but with a minus for the middle. So it's x squared minus 2 times x is 4x, and then plus 4 squared, 2 squared, so which is 4. Now we're just going to simplify it. The first bracket is x plus 2 minus x plus 2. So the x's will cancel out. 2 plus 2 is 4. Don't actually need that bracket. Now, when I've got a long expression like this, I like to use something to tick off the terms so I can keep track of what I've added up, what I haven't. X squared, 2x squared, 3x squared. Okay, next. 4x minus 4x is 0. 4 minus 4 is 0, plus 4 is 4. So weirdly, that goes all the way to a very simple expression of 4 outside of 3x squared plus 4. Double checking, did I tick everything off? Yes, I did. Have I done this bit right? I think I have. So I believe that this is the a proper factorization of this particular expression. Amazing, but true. I'll leave it there. There's lots of different kinds of examples. This is just supposed to provide you with a brief sample so you can sort of see how to apply the rule. But the thing to focus on is really challenging yourself to identify what the 2 different terms are that you're adding or subtracting so that you can apply the sum or difference of cubes rule. Have a go at doing some problems.